All right, today we're jumping into something I think we can all relate to Lego bricks. But we're going to mix that with a little artificial intelligence and see how AI is trying to master one of the most beloved and, let's be honest, chaotic hobbies on the entire planet. Yeah, if you've ever played with Legos, you know this feeling. That sound, the sights, the just sheer overwhelming presence of the big pile, right? The giant tub of bricks just dumped out on the floor. It's such a universal experience for any Lego fan. I mean, inside that pile is everything. It's every spaceship, every castle, every race car you could possibly imagine. But it's also just a total mess. And trying to find that one specific piece, it can feel absolutely impossible. So what if AI could finally bring some order to all that chaos? Okay, so let's get into it. It turns out developers are already on this. They're creating these AI-powered apps that basically act as your own personal Lego assistant. So right now, two main apps have really popped up, and they're interesting because they answer two totally different questions. You've got Brickit, which is really for the builder, the person who just wants to create something cool. And then there's BrickScan, which is for the collector, the person who wants to catalog and organize everything. And the way Brickit works is it's beautifully simple. You just spread out your bricks, you snap a photo with your phone, and the app's AI gets to work, scanning and identifying all your parts. And then, this is the cool part, it suggests things you can actually build with what you have, complete with step-by-step instructions. It literally turns your random pile of parts into this curated menu of possibilities. It's awesome. Now, on the other side of the coin, you've got BrickScan. And this thing is an absolute powerhouse for the serious collector. It uses AI to identify over 16,000 unique minifigures, and get this, more than 76,000 different parts. You can track your entire inventory with it, and it'll even give you an estimated value. It's basically a digital catalog for your physical collection. Okay, but let's be real. Pointing your phone at a pile of plastic and having it recognize every single tiny piece, that feels like straight up magic. But of course, it's not. So how does it actually work? All right, let's pull back the curtain and look at the actual science that makes these apps tick. It really all comes down to one thing: computer vision. This is a field of AI that's all about training computers to see and understand images. Just like our brains process what our eyes see, computer vision teaches a machine to identify objects, shapes, and patterns in a photo. Now, you'd think that recognizing the iconic shapes of Lego bricks would be the hardest part, right? A 2x4 is a 2x4. But actually, one of the trickiest problems for the AI is something we totally take for granted: color. And this is a huge hurdle. I mean, researchers who built a whole dataset just to solve this problem put it perfectly. They said the same brick in direct sunlight looks completely different from that exact same brick in a dimly lit room. Our brains, we automatically adjust for that. But a camera, it just sees two totally different sets of pixels. So this is the crucial part. The AI has to be painstakingly trained on thousands and thousands of images just to learn that a brick that looks light gray and one that looks dark gray and one that looks medium gray might all be the exact same piece, just seen under different light. It has to learn what color consistency actually means. Okay, so the AI is getting really good at identifying all the parts and figuring out their true colors. So it stands to reason that the next step, actually understanding how to build with them, that should be easy, right? Well, not so fast. And this brings us to the reality check. This is where even the most powerful, cutting-edge AI models run into some surprisingly human-like problems. So researchers recently put this to the test. They used this benchmark called Lego CoBuilder to see how well one of the most capable models on the planet, GPT-4o, could handle the seemingly simple task of just following Lego instructions. And the results were pretty fascinating. The paper found that the model just kept failing at one very specific thing: spotting when a part was placed incorrectly. It could see the part, sure, but it couldn't really reason about its precise location relative to all the other parts. So just how bad was it? Well, in the world of AI, researchers use something called an F1 score to measure accuracy. 100% is perfect. On this critical task of spotting a mistake, the AI scored just 40.54%. Yeah, to put it simply, that's worse than a coin flip. The AI can identify all the objects in the scene, no problem, but it has this profound lack of spatial and procedural understanding. It doesn't get the why and the where of the building process. So why is this so hard? I mean, why can an AI write a poem or a bunch of code, but it struggles to tell you if a simple 2x4 brick is in the right spot? The answer, it turns out, is way more complex than you might think. Because the real challenge here isn't just about seeing bricks. It's about understanding a massive, incredibly intricate system that was built not by programmers, but by fans. See, when an AI looks at a Lego part, it's not just identifying a shape. It's trying to tap into this enormous, fan-created database, a kind of Legopedia, if you will, that's been evolving for decades on websites like Rebrickable. And this right here, this just illustrates the complexity perfectly. This is the language the AI has to learn. And these are not random numbers. 970CXX is a super precise code for a minifigure's legs, and it specifies the main leg color and the color of the molded boots. Or look at 973GXXCXXHXX. That defines a torso with dual molded arms, specifying the upper arm color, the lower arm color, and the hand color. It's an incredibly dense, unbelievably specific system. And here's the thing, this system wasn't designed by some neat algorithm. It was built piece by piece by a global community of super passionate fans, cataloging tens of thousands of unique parts over decades. So for all its power, the AI is basically the new kid in a very, very old school, just trying to learn a language that grew organically out of human passion. So when you think about it, AI isn't just solving a technical problem here, it's learning to interpret a culture. It's this powerful reminder that behind all of our hobbies and collections, there's this deep well of human-generated data and structure. And that just leaves us with a really fascinating question. What other worlds of human passion will AI learn to navigate next?